So hello guys and welcome to my channel. Today in this video we'll discuss some important numericals that are frequently asked in the power electronics subject. So here starting with the first numerical, here we have the first numericals. A full bridge inverter produces a square wave of 100 volt peak and find the peak value of load current for a load having. Here we have the value of R given as 10 ohm. Similarly, the value of L is 50 millihenry and the output frequency is 50 Hz here. And this is the numerical for full bridge inverters. So here, starting the solution, here we have the frequency given as 50 Hz and we know omega equal to 2 pi f. So if we substitute, we can simply get the value of omega, or we can directly use the value of omega as 314.16 radian per second. And for full bridge inverters, we have the value for VL equal to summation n equals to 1, 3, 5 and 7 to infinity, and 4V upon n pi and sin n omega t. So remember this formula for full bridge inverters. So once you will remember the formula, you will be able to calculate such type of numericals. So here we have VL equals to summation n equals to 1, 3, 5, 7 to infinity and 4V upon n pi sin n omega t. And here 4 into V, and in place of V here we have 100 volt given. So 4 into 100 upon pi, and here we have 4V upon n pi is taken common here. So sin n omega t. So for n equals to 1, here we have sin n equals to 1, and in value of omega is 314.16. So 314.160 plus again 1/3 means 1 by n is given here. So for n equals to 3, here it will be 1 upon 3, and sin n omega t. So value of n for n equals to 3, we have 3 into 314.160 plus similarly for n equals to 5, here we have 1 upon 5 sin 5 into 314.160, and similarly for n equals to 7, here we have sin 7 into 314.160. So here if you solve this, you will get here 127.32 sin 314.160 plus 42.44 sin 942.480 plus 25.46 sin 1570.80 plus 18.1t sin 2199.1t. And here you can see, as the value of n goes on increasing, here you can see the amplitude. Here first amplitude is 127.32. Similarly for n equals to 3, here we have 42.44. Similarly for n equals to 5, here we have 25.46, and similarly for n equals to 7, here we have 18.18. So here we can see, since the amplitude of harmonics decreases as n increases. So yes, the amplitude of harmonic goes on decreasing as the value of n is increasing. So harmonics higher than 7th can be neglected here. So just so that's why we have taken just 1, 3, 5 and 7. And here for load impedance of various harmonics given. And here we have for RL load given, R and L is given. So full bridge inverter for RL load. So to calculate the load impedance, here we have 0 equals to R plus J omega L, and in place of R we have 10 ohm given in the questions plus J, and in place of omega here we have 314.16, and in place of L given in the question as 50 millihenry. Here the value of L is given as 50 millihenry. So here once you calculate, you will get here 18.62 and its angle will be 57.5 ohms. And similarly for J3 10 plus, and for n equals to 3, here we have 3 into 314.16, and again value of L is 50 millihenry. So 50 into 10 power minus 3. So just solve this with the help of calculators, you will get this value as 48.18, angle will be 78 degree. Similarly for Z5 10 into, and this is for n equals to 5, so 5 into 314.16 into 50 into 10 power minus 3, and that will be 79.18, and its respective angle will be 82.75 ohm means degree. Similarly for Z equals for Z7, and so it will be 10 plus J 7 into 314.16 into 50 into 10 power minus 3, and it will be 110.42 and its angle will be 84.8 degree. Now to calculate the load current, here we have IL is equals to, here we have obtained the value of VL and its respective means Z1 is given here, Z3 is also given, and also we have calculated for Z5 and Z7. So I is equals to V upon R and sine 314.160, and here you can see here its angle is given as 57.5 degree. And for first case, for fundamental, here for n equals to 1, here we have sine 314.160. so if we substitute the value here, we will get 127.32 upon 18.62 sine 314.160, and right now the degree will be subtracted here, minus 57.5 degree. Similarly for n equals to 3, here I have written, and for n equals to 5, similarly this is the case for n equals to 7. So on further simplification, we will get here 6.84 sine 314.160 minus 57.5 plus 0.881 sine 942.48 minus 78 plus 0.32 sine 1570.80 minus 82.75. Similarly for n equals to 7, here we have 0.165 and sine 2199.12 t minus 84.8. Now we have to calculate the peak value of current. So for peak value of current, here we can write, here you can consider this value 6.84, means its amplitude 0.881. Similarly this value 0.32 and 0.162. So 6.84 square plus 0.881 square plus 0.32 square plus 0.165 to the power 0.5 means it will be under root under, means it is root under 6.84 square plus 0.881 square plus 0.32 square plus 0.165 square. So you will get here 6.91 ampere. Now the second one, here we have 4 single phase full bridge inverters, and here we have given the data input DC voltage given as 100 volt. Here we have the DC voltage given 100 volt. Similarly the frequency is given as 50 Hz, and the load inductance, means the value of EL is given as 10 millihenry, and the value of R is 20 ohms. And here you have to calculate the RMS load voltage. Similarly RMS value of fundamental component of load current, and in the third one we have to calculate the peak value of load current. So for single phase full bridge inverters, the RMS load voltage will be 2 upon T, and here in root under it will be 2 upon T and integration 0 to T upon 2 and B square dt. And simply for single phase full bridge inverters, the RMS load voltage will be exactly the input DC voltage, and here we have given the input DC voltage as 100 volt, so we can directly write it as 100 volt. Now similarly the expression for output voltage is given as VR equal to summation for n equals to 1, 3, 5, 7 and to infinity, and 4V upon n pi sin n omega t. So this is the expression for output voltage, means VL. And then now here if you substitute the value of value of voltage, similarly for n equals to 3, and as previously solved in the question number 1, if you substitute just like that, we will get the value of VL as 127.32. This is the case for n equals to 1. Similarly 42.44, and this is the case for n equals to 3. Similarly this is 25.46 sine this value, and this is for n equals to 5. Similarly this value is for n equals to 7. And now load impedance of various harmonics. Similarly this numerical is also for RL load, and here you can see the value of R is given as 20 ohm and the load inductance is given as 10 millihenry. So here the load impedance for various harmonics will be Z1 equals to R plus J omega L. So R value of R is 20 plus J omega, in place of omega we can write 314.16, and in place of L we will have 10. millihenry, means 10 into 10 power minus 3. So you'll get here 20.24 and its angle will be 8.92 degree. Similarly for Z equals to 3, so 20 plus J, and this is for J3, so value of N will be 3, so 3 into 3 14.16 into 10 into 10 power minus 3, and it will be 22.1 and its respective angle is 25.22 degrees. Similarly for N equals to 5 you can calculate the value of Z5 and its value will be 25.43 and its respective angle is 38.13 degree. Similarly for N equals to 7 the value of Z7 can be calculated here as 20 plus J7 into 314.16 into 10 millihenry is given, so 10 into 10 power minus 3 and it will be 29.72 and its angle will be 47.71 degree. Now we have to calculate the load current IL. So IL will be this V upon R, V upon Z impedance, and here just now we have calculated VL. So VL is 127.32 sin this value, similarly 42.44 and sin this value. So in order to calculate the load current, IL will be 127.32 upon this Z1 value, and Z1 value is this 20.24 and its angle is 8.92. So angle will be just right now it will be subtracted. So 314.60 minus 892. Similarly IL for here 42.44 is given for N equals to 3. Here we have for N equals to 42.33 given and it's sin 942.48 T given. Similarly this is for N equals to 3 and similarly the Z3 is given as 22.1 given and its angle will be right now this, so sin 942.48 minus 25.22. Similarly we can write for N equals to, this is for N equals to 5 and this is for N equals to 7. So once you solve this you will get the value of IL as here, means 6.29 sin 314.160 minus 8.92. This is for off. So 6.29 sin 314.16 minus 8.92 plus 1.92 and sin 942.48 T minus 25.22 plus 1.001 and sin 1570.8 T minus 38.13 plus 0.611 and sin 2199.1 T minus 47.71 given. Now resistance, and here we have to calculate the RMS value for fundamental component of load current. So RMS value for fundamental component means we have to calculate for here N equals to 1. For N equals to 1, here we have given the IL as 6.29. So we have to calculate the RMS value. So for RMS value, you have to divide by root 2. So 6.29 upon root 2 will get here 4.448 ampere. And peak value of load current will be the root under this value means a square of this value plus a square of this value plus a square of this value and plus a square of this value. So we can write here 6.29 square plus 1.92 square plus 1.00 square plus 0.611 square power 0.5. So once you solve this, you will get here 6.68 ampere. Now here we have the next one as this is also for full bridge inverter circuit, and right now this is the case for RLC load. And here you have the full bridge inverters. Full bridge inverter said here circuit has an input voltage of 200 volt. Input voltage is given as 200 volt, and here the load is series RLC circuit. And here you have the load given as RLC and its respective value is given as R equals to 10 ohm. Similarly value of L is 20 millihenry and the value of C is 100 microfarad, and the inverter frequency is 50 Hz. And here the inverter frequency given as 50 Hz. And in this question, so we have to express the instantaneous load current on Fourier series and consider the harmonics up to 9th harmonics only. And here we have to consider harmonics up to 9th. So previously we have considered up to 7th, and right now in these questions it is said to consider harmonics up to 9th, means up to the 9th harmonics. And here we have to calculate the RMS value of fundamental component of load current and peak value of load current, similarly RMS harmonic load current and total harmonic distortions, and in E find the total output power and fundamental component of output power, and the average input current and the peak value of thyristor current. And the load impedance has to be found for right now up to in the questions it is said to consider the harmonics up to ninth, means up to the ninth harmonics. So we will consider for n equals to 1, n equals to 3, n equals to 5, n equals to 7 and n equals to 9. So first we'll calculate Z1. So Z1 will be 10 plus j omega L and minus, and capacitive load is also given, so 1 upon 2 pi fc it will be. So 10 plus j omega L means 2 pi f into, in value of L is 20 millihenry, so 20 into 10 by 10 to the power minus 3 minus 1 upon 2 pi fc, and the value of capacitor is given as 100 microfarad. So we'll get here the value of Z1 for n equals to 1. So its value will be 27.437 and its respective angle will be minus 68.63 degree. Similarly for Z3, means for n equals to 3, the value of Z3 will be 10 plus j, and right now we are calculating for n equals to 3, so 3 into 2 pi fl, and value of L is 20 millihenry, and minus 1 upon 2 pi fc. 2 pi fc, and also you have to consider n equals to 3, so 3 into 2 pi fc, and value of c is 100 into 10 power minus 6, means 100 microfarad given. So on solving we will get here 12.96, angle will be 39.45 degree. Similarly we can solve for Z5. So Z5 will be 26.96 and its respective angle will be 68.22 degree. Similarly Z7 will be 40.66 and its angle will be 75.76. Similarly you can calculate Z9. Now here we know to calculate, we know we have VL. Here we have the expression for VL, and here we will consider the harmonics up to 9th. So n equals to 1, 3, 5, 7 and 9 up to infinity. And here we have 4v upon n pi and sin n omega t. So 4v upon pi will take common, so 4 into v, and value of v is 200 given, upon pi, and sin for n equals to 1 it will be 314.160. So 4 into 200 upon 3 pi means n equals to 3, and this is the case for n equals to 3. Similarly this is the case for n equals to 5, and this is the case for n equals to 7, and this is the case for n equals to 9. So once you solve you will get this value. Now its load current will be IL will be, and here we have just now calculate the value of VL. IL will be VL upon its respective impedance. So VL is given as 254.65, this is for fundamental. Similarly 84.88, this is for n equals to 3. Similarly for n equals to 5 we have 50.93, and for n equals to 7 we have 36.838, and similarly here its respective impedance is given Z1, Z3, Z5, Z7 and Z9. So now IL will be here, IL will be the VL upon its impedance. So once you solve we will get the value as here 0.9 means 9.28 and sin 314.160 plus 68.63, and here we have, here you can see in Z1 the angle is minus 68, so right now it will be positive here. So here we have plus 68.63. Similarly for n equals to 3, here we have similarly for n equals to 5, n equals to 7 and n equals to 9. And in the second we have to calculate the RMS load current at fundamental frequency. So at fundamental means n equals to 1. So for n equals to 1 here we have 9.28, and you have to calculate the RMS load current. So for RMS we have to divide it by root 2. So you will get here 6.56 ampere. Now peak value of load current will be, so peak value of load current will be the root under this value square and the square of this value. Similarly the square of this value and plus the square of this value, and similarly the square of this value. So here you can see the peak value load current is 9.88 square plus 6.55 square plus 1.89 square plus 0.9 means 0.895 square plus 0.525 square to the power 0.5. So you'll get here 11.56 ampere. Now RMS harmonic current. So to calculate the RMS harmonic current, we can write here this value means 11.56 square minus means the load current at n equals to 1, and here the load current at n equals to 1 is, here we have 9.28 given. So 9.28 square to the power 0.5 and RMS, so for that we have to divide it by root 2. So we'll get here 4.875 amperes, and total harmonic distortion will be 11.56 square minus this 9.28 square power 0.5 upon this value, means at n equals to 1 its respective value for IL is given here for n equals to 1. So harmonic distortion will be 74.3%. Similarly here RMS value of load current. So to calculate the RMS value of load current, here we have calculated the value of peak value of load current. So 11.56 upon root 2 will get the RMS value of load current here. So we will get here 8.175 ampere, and here we have total output power. So total output power will be I square R, means RMS value of load current into R, value of R is 10. Here you can see here in the questions the value of R is given as 10 ohms. So total output power will be here 668.3 watt, and fundamental component of power will be here. So for fundamental component, here we have, you can see here we have RMS value of load current at fundamental is given as 6.56. So the RMS value of means fundamental component of power will be 6.56 square into R, and value of R is again 10 ohms. So you get at 430.336 watt, and average input current will be means total output power upon this input voltage, and input voltage 200 volt given, so 3.3415 ampere, and peak thyristor current will be the same value of here this peak value of load current. So here peak thyristor current will be 11.56. Now here we have the next one, and here we have the next numerical as a 3-phase bridge rectifier has a purely resistive load of R, and determine the efficiency VA rating of transformer and the peak current through the diode, and if the rectifier delivers 60 ampere at the output voltage of 280.7 volt, and assume the source frequency to be 60 Hz. So here we have the 3-phase bridge rectifier. So we have the formula as VDC is equals to 3√3 upon pi into Vm. So just remember this formula, and if you just solve this, you will get here 1.654 Vm. And similarly for IDC it will be 1.654 Vm upon R, and VRMS will be 1.6554 into Vm, and IRMS will be 1.6554 Vm upon R. So just you need to remember the formula. So here PDC will be means 1.654 Vm square upon R. Similarly PSC will be 1.6554 Vm square upon R. Here we have given value of VDC and IDC is given here. So here efficiency will be right now PDC upon PSC into 100, and PDC is given as here 1.654 Vm upon R. Similarly PSC is given 1.6554, and this value in Vm, so we will get here 99.83%. And to calculate the voltage rating of transformer, here we have voltage rating as 3 Vs into Is, so 3 into and in place of Vs we can write Vm upon root 2 into Is, and where the value of Is can be calculated as Is is equals to 0.7804 Ims. So these all are the formulas, just remember this. 0.7804 into, and to calculate Im we have to do multiply with root 3 into Vm upon R. Now voltage rating will be, if you substitute the value of Is here in this, you'll get the voltage rating, means VA rating, voltage ampere ratings. So you'll get here 2.86694 Vm square upon R. Now peak line to neutral voltage, means Vm is equals to 20, means 280.7, and here we have here output voltage is given as 280.7 volt given here. So Vm will be here, right now Vm will be 280.7 upon 1.654, and that will be 169.709 volt, and again that will be equals to the V naught upon DC, means this is V naught upon VDC to calculate the value of Vms. So you'll get here 169.709 volt, and peak inverse voltage will be root 3 into Vms. Just now we have calculated the value of Vm here, and that is 169.709. So peak inverse voltage will be root 3 into Vms. So if you solve, we'll get here 293.94 volt. And now average current through each diode is calculated as ID is equals to, and this is also the formula to calculate the diode current. ID is equals to 4 upon 2 pi and integration 0 to pi upon 6 and Im cos omega t into d omega t. And now here we have Im will be ID is equals to Im into, if you solve this we will get Im into 2 upon pi and sine pi upon 6, so and which is going to give 0.3183 Ims. So just solve this, you will get here 0.3183 Ims. And again average current through each diode is given as 60 upon 3, since 60 ampere is given, and here we have in the question, here you can see the diode if the rectifier delivers 60 ampere at the output voltage. So the average current through each diode will be 60 upon 3, and that is going to give it 20 amperes. Now peak current Im, so to calculate peak current Im will get ID upon 0.3183, and that is again going to give 62.83, means here we have the relation ID is equals to 0.3183 Ims, and from this we have calculated the value of Im, and Im as 20 upon this value means ID, and just now we have calculated the value of ID as means 20 amperes. So Im equal to ID upon 0.3183, so you get here 62.83 amperes. So the voltage rating will be 2.86694 into, and here we have 169.7 square upon R. Here you can see the voltage rating is 2.8694 into Vm square upon R. So just we have substitute the value of Vm and R here. So voltage rating will be, so here voltage rating as 2.86694 into 169.7 square upon R. So we will get here 82562.39 upon R here. And to calculate the form factor we have Vrms upon Vdc, and we have Vrms obtained here 1.6554 upon Vdc as 1.654. Since here we can see previously we have seen all the formula for Vdc. Here we have seen the formula for Vdc as 1.654 Vm and Vrms as 1.6554 Vm. So just you need to remember the formula, and then you can easily solve all the numericals. Similarly here ripple factor is Rf equal to form factor square minus 1, and here form factor equal to 1.008, just now we have obtained. So square will get here a ripple factor as 0.004. Now here and we will discuss further numerical in the next lectures. Thanks for watching and please don't forget to subscribe to my channel. Thank you.